In this video, I'm going to talk about scientific theories versus scientific laws. As a reminder, write the notes that are in orange, and your vocab words will appear in pink. Let's take a moment to look at this cartoon. You'll understand the meaning behind it by the end of this video. Okay. So our learning objectives. I want you to explain that scientific laws are descriptions of specific relationships, but they don't offer explanations. I want you to recognize that theories do not become laws, nor do laws become theories. Theories are well-supported explanations, and laws are well-supported descriptions. Then you will explain that a scientific theory is the result of many scientific investigations. It is the most powerful explanation scientists have to offer. So let's start with theories. Developing theories. Once a hypothesis passes the test of repeated experimentation, it may be raised to a higher level of ideas and it will become a theory. The definition for a theory is it's a well-tested explanation for a broad set of observations. So you have to observe something first, and then it is tested many times, and then it provides an explanation for what you observed or what you saw. And remember, we talked about yesterday that observation is the beginning of the scientific method. So you have to first observe a problem, come up with a question, then you have a hypothesis, and you have to repeatedly test it, and then it will become a theory. A theory can never be proven. This does not mean that it's unreliable. It simply means it's open for the possibility of change at some point in the future. This is very important when explaining new observations or experimental results. As technology improves, our knowledge will improve. As technology improves, that means that there is potential to find new observations or find new results and new findings. And that's how these theories can be changed. On the flip side, a scientific law summarizes and describes the results of many observations and experiments. So you start with an observation, and then it becomes a hypothesis, and then it becomes an experiment, or you have to experiment what you were hypothesizing, and then your experiment can lead to observations that support or disprove a hypothesis. You have to have many repeated experimentations, and then it has the potential to become a theory. The theory can then be experimented again, and then the theory can be revised or modified if needed. However, let's note here, I have it here in the white, a theory does not become a law, and a law does not become a theory. There isn't an arrow that jumps between the two, but the experiment can become a theory, and the experiment can become a law. So a law doesn't try to explain the relationship it describes. A law just describes events, and they're often mathematical. So for example, the law of gravity is all objects in the universe attract one another. So basically, if you let something go, it falls. Another example would be an object in motion stays in motion unless acted upon by an outside force. Another one is the sun always sets in the west. Now, this describes what happens, and it summarizes an event, but it doesn't explain what gravity is or how it works. So it doesn't give you the why or the explanation. 3 centuries later, Albert Einstein developed the theory of relativity, and then scientists were able to understand what gravity is and how it works. And the theory of relativity gives you the explanation as to why law of gravity works the way it does. But that was 3 centuries later. So now I want you to think, what are 2 phenomena or events in nature, and think about a hypothesis for both of them. And do you think your events would be described by laws or explained by theories? So the example I want to give you is the origin of the universe. So the origin of the universe, how the universe began, like if you hypothesize how the universe began, that could be explained by the Big Bang Theory. So it's not a law, but the explanation for the origin of the universe is a theory, the Big Bang Theory. That all objects in the universe attract one another, that's the law of gravity. It doesn't provide an explanation, it just gives you a description of what will happen with objects in the universe. They will attract one another. So finally, I want you to draw this picture, comparing and contrasting scientific law and scientific theory. So the first thing is it tells you, the scientific law will tell you what happens. Example, what color eyes will your kid have? Or what happens if you let a ball go in the air? So this one is the law of heredity. And then the scientific theory tells us why something happens. Example, the Big Bang Theory, or the theory of evolution. Why or how was the time? And the way that they are similar is right here in the middle. So both a law and a theory have to be supported by lots of data. Both can change with new data or technology, and both of them are based on a hypothesis. Okay? So the scientific law it describes, and the theory explains. So I would add that in there. Okay. Laws are descriptions, theories are explanations. So that answers that question. Okay, and that is all I have for you for this video. Thank you.